We've learned a lot in this introduction to metabolism, and there's one more thing that we need to carry on for the next several weeks as we go through different pathways. We're going to see a lot of different reactions. And one of the most important skills we can have is to categorize those reactions into similar chemical steps. And biochemists have done this in the past and come up with 6 types of reactions that all biochemical reactions can be categorized into. And this is something we need to practice, and we're going to do so in homework, and we're going to be using this every time we see a new reaction. You're going to be asked which of the 6 types of reactions is it. These are actually in a particular order. It's not just a random set of 6. Number 1 is oxidation reduction reactions. Number 2 is group transfer, etc. So let's jump in and deal with these one at a time. Many of them we already know how to do. Oxidation reduction reactions is one we've already talked about. That's going to be the transfer of electrons from one molecule to another. That's often going to be in a transfer of a hydride ion, the H minus that we talked about a lot in previous videos, but it's really all about the electrons. Now the key is that when you do an oxidation reaction, you must have a reduction. In other words, when you remove a pair of electrons from a molecule, they must go to a different molecule. They can't just be floating around in space. Let's take, for example, this reaction, which is really important for human medicine. If you take some alcohol from beer or wine or spirits or whatever, and you have that in your body tries to detoxify that. And the liver is what does that. And the liver can change ethanol here in your blood to acetaldehyde. And acetaldehyde is also problematic, so it's further consumed, or rather converted into acetic acid, which is really not bad for us. Now, when we look at this, we can see that ethanol is being changed to acetaldehyde, and we can also see that NAD plus is being changed into NADH. So let me ask you, what is being oxidized and what is being reduced in this particular reaction? Take a moment, pause the video, and see if you can come up with the answer for that. So like I said, every oxidation reduction reaction can be split into 2 processes. The alcohol to aldehyde is being oxidized and the NAD plus being filled up. Remember, we think of it like a basket. It's being filled up with a pair of electrons. Therefore, it is being reduced to NADH. Now, there are some terms that we use here from time to time that are useful. If the ethanol is giving its electrons to the NAD plus, as we see here, then it's the ethanol that is going to be referred to as the reducing agent. Now look at that. The ethanol is becoming oxidized, but it's causing NAD plus to be reduced, so we call it the reducing agent. NAD plus is causing ethanol to be oxidized, so we call that the oxidation agent. Okay, we're 4 minutes in and we've only done 1. Let's move on. Number 2 is group transfer. We've also seen this type of reaction, and what it typically means is the transfer of a phosphate group from one molecule to another. And you can see this ATP has given its phosphate over to the 5th carbon of deoxyribose here, and we end up with that phosphate group being transferred. So it's typically phosphates, but it's not always. It could be a lot of other things. So keep that in mind. It's going to be transferred from one molecule to another. Hydrolytic cleavage. That one's pretty easy for us. We've seen this many times before. Here's a classic example where a peptide bond in this little dipeptide is being broken into its constituent carboxylate and amino groups with water added across them. This is going to work on things like amides, esters, phosphoesters, glycosidics, all the ones that we talked about that create a water when they're formed. Good, let's move on. Number 4 is going to be what we refer to as lytic. Sometimes we call this non-hydrolytic cleavage, or sometimes we just call it lytic. And this takes 2 flavors. The first one is carbon-carbon bond breaking or making. We haven't done that at all in this class, even though it's really important. Take this molecule here, which is 5 carbons, break it into a 2-carbon and a 3-carbon molecule. That's a lytic reaction. They're tougher to do, but we're going to see some examples coming soon. There's another type of lytic reaction, and it's called addition-elimination. You may remember additions and eliminations from your other classes like organic chemistry. And here, for instance, is an alcohol. And if we take an alcohol and eliminate a water, we end up with a double bond. That would be an elimination. Or we could take a double bond and add a water across it and get an alcohol. That's also lytic, and those are 2 very different types of reactions in some ways, so be careful with that. Next, number 5, isomerization. We've seen lots of isomerizations before. This is going to be pretty easy for the most part. Like for instance, here we have glucose 6-phosphate to fructose 6-phosphate. It's going to be of some interest if we can go back and figure out what type of isomerization some of these things are. This is an aldehyde-keto isomerization back from our sugar chapter. The key for isomerization is that you end up with the exact same number of each atom in the substrate and the product. And what happens there is they're just simply rearranged into a different form. Lastly, number 6 here is called ligation. We are not going to see ligation at all in this unit. We won't see it till our final unit. And that means let's skip this for now. We will come back to it and discuss it later. It will not be in your homework. It will not be on your exam, but we will see it later in the class. So 1 through 5 here is going to be what we're going to be working on. And to get ready for your homework, let's go to the next page here, and let's see if you can come up with which of the 6 types of reactions this reaction is, and which of the 6 types of reactions this one is. These are a little bit weirder, and I just wanted you to try them out. So pause, and let's see what you come up with. Okay, these are actually all reactions that we are going to see, and I want you to be ready to see this kind of thing. When we see a alkane like this becoming an alkene, that has to be an oxidation. Remember, when we do a transformation of an alkane to an alkene, that is a dehydrogenation. That is what we mean when we say that we are removing a hydride ion or the equivalent of a hydrogen molecule, and we have therefore removed a pair of electrons. Now, I told you something earlier, that you cannot have an oxidation without a reduction. So this reaction as drawn is problematic, and what it means is we actually have to have something added to it. And what we typically need is some kind of a molecule to put the electrons on. And what we use for this case typically is a basket, like we talked about earlier, not NAD plus in this case, but FAD, and that becomes FAD ... H2 as those electrons fill up that basket. So that's a number 1 reaction, oxidation reduction. What about this one over here? This is tricky because what we're doing, if you look at this, you always got to look at what's changed chemically. And this one messes people up a little bit. This phosphate group right here is being moved over next door. A lot of people guess that this is a group transfer. And they reason that, well, the phosphate group is being transferred from one carbon to another one next door. But it's not. A group transfer only means we transfer phosphates between molecules. This is within a molecule. Therefore, this is an isomerization. So we'll get that written out. You can go to it. on your homework, and we'll put this one to rest.